All right. Welcome back. I hope that was a good brain break. Let's pick up with this request for a mathematical relationship for this object's motion that relates velocity, position, and time. Okay, so I've got a graph here of velocity, where velocity is just some constant number, right? So where did that number come from? So I could just say velocity equals some number, right? It's a constant number. It makes sense. We're in a unit called constant velocity motion. But we got that number from the previous type of graph, which this is not the same information, but this is a position time graph. We got that velocity from finding the change in position divided by the amount of time that went by. You will recall that that was one of these definitions, right? Here. So go back here. Velocity is change in position over change in time. Now, it turns out you've actually seen this equation before. So this velocity is position change over time. Look back here to this last position time graph. There's all those same quantities there, just rearranged in a different order. So this is nothing more than a different way of looking at exactly the same information we've already seen. All right, we're going to try, I think now is when we see a different example. What do you see on this graph? I'll give you a little wait time to think about this first 3 questions on here. Okay, so perhaps you're going to want a little explanation, especially on that last point there. Sketch the position versus time graph of this same motion. You'll notice that across the entire graph, this object's velocity is negative. It stays at a constant negative velocity. That means this object's got a negative slope on the position time graph. And if you were watching closely a minute ago, you may have seen me initially draw a positive slope and then realize my mistake and erase it. That slope of this graph is the same as the constant velocity. Whoops, I went off the line. That constant velocity value that we see all the way across this graph. All right, cool. So I'm going to skip ahead here and encourage you to revisit problem set 2. Because you've got a sub in and out of the classroom today, I'm going to ask you to work together and stay focused on the task at hand. So everybody who's sitting at table 1 right now, I want you to work together on problem number 4 in this problem set. You're going to solve the problem and put it on a whiteboard. Table 2, you've got problem 5, and so on down the list. Give yourselves 5 to 7 minutes to create those problems on whiteboards. Discuss among your group, get the whiteboards put together, and then present to each other and come to consensus. After this approximately 20-minute long activity, everybody in the room should agree on the correct solution to problems 4, 5, 6, and 7 out of problem set 2. If questions still exist, please elect one person in class to drop me an email with what the question is specifically. Hey, we really struggled with question 7, for example. And then the final step in class is that the sub is going to come back in the room and they're going to give you quiz number 1. Quiz 1 has nothing to do with the new information we learned today. It's only about position time graphs and a little bit of vocabulary. You are welcome to use any of your notes on this quiz. And when you're done, set your finished quiz up on the podium and I'll collect them after Rosh Hashanah ends. Your homework, it's on Canvas, but it is to do problem set 3. You have that in your packet of problem sets. Thanks so much for your attention today to these videos, and I look forward to seeing you in the next class, which for me is also the Jewish New Year. Take care. Shana Tova, everybody. Bye-bye.